All right, guys, thanks for coming today to a R workshop, gentle introduction, being put on by Dr. Michael Peabody. He's a psychometrician, senior psychometrician at the American Board of Family Medicine here in Lexington, Kentucky. And I'm not going to speak too much because it's his showcase today, but I just want to briefly say thank you for showing up today. Hopefully you guys learn a little bit about R and we'll start using it more. But without further ado, I'm going to turn it over to Mike.
Thanks. So I had the handout circulated, just kind of a little outline of what we're going to talk about. And the first thing is, what is R? So R is somewhat different than SPSS and SAS and other programs, and then it's an object-oriented programming language. It actually was invented at Bell Laboratories as the subsequent version to the S programming language that they use. So it is kind of like, you could use it in the way you use SPSS or SAS or some of these other data analysis tools. It also does a whole lot of other things. So we're going to start by just kind of getting in, downloading it, and taking a look around at what some of the very basic functions of it are. So the first thing we're going to do, and please feel free to stop me and ask questions whenever you have anything. I want you to go to rstudio.com. So R itself is a very basic, stripped down, kind of a bare bones program. RStudio is a much more user-friendly GUI, graphical interface that sits on top of R. It does just some of your basic stuff much more easily than you would do just by hand coding everything. So in RStudio, where is it? Go down here to download. And the desktop edition here, it's free. That's another basic nice thing about R is it's free. As SAS and SPSS and all those get a lot more expensive, R is not. Then the first one, just download the first one, RStudio. Actually, we should probably download R first. So let's do that. Right here it says, if you don't have R, download it here. You really can't see it on the screen, but there's a little box there. Click that, and you go to the Comprehensive R Archive Network, what they call the CRAN. The CRAN is where all of the officially, I don't say licensed, that's another word, but the vetted packages go. And I'll talk more about packages in a bit. So if you want anything from R to add on, because R comes with its base model, with just the nuts and bolts, correlations, t-tests, those kinds of things. But a lot of people have written a lot of really cool packages to do more with it. And those you have to download from the CRAN. It's just a series of mirror servers all across the world. So just go to the CRAN and hit download for Windows and install R for the first time right over here. And download R 3.4 for Windows. Save. I just do the standard installation for everything. I don't get crazy with all of the different, I just use the defaults. It's usually just much easier. It just takes a minute. It actually is a relatively large executable.
What's your experience with R with Macs?
A lot of people use R with Macs. It is not uncommon that it is one of, I don't know that it's as popular as Windows, but it's right there with it. Yeah, you shouldn't have a problem with R for Macs either. I mean, it's built for, obviously, Windows, Mac, and Linux. So if you've got a Linux box at home, you can put R on it too. All right, we're gonna run. Yes. In English. Yeah, this is just letting you know this is free. It doesn't come with any warranties whatsoever. Yes, no, except the defaults. Yep. I just clicked straight through all the defaults. Yes, 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 yes.
You like your gentle approach.
Well, the thing people talk the most about R is what a steep learning curve it has. the learning curve isn't so much about the program, it's about how to think like an R user. So it requires you to think a little bit differently than the way you think about SPSS flat files.
What's a flat file?
Like an Excel file, just rows and columns.
Okay.
That's it. Finish. Okay. And so here you see on my desktop now I have the R64 shortcut. You click on that. This is your basic R console. It is not. There's not a whole lot going on. It's just a single line, command line input. That's it. Okay, so now I'm going to switch over, and now that we've got the our base R version downloaded, now I'm going to install the R Studio. R Studio, it's already in there. So just go to. So I've already downloaded it, so I'm just going to. There it is, right there. Yep. And again, I'm just installing all of the base options using all of the defaults. So one of the things about R that is not problematic but somewhat frustrating at times is that there is no upgrade button. When the next version of R comes out, you don't upgrade to the next version. You delete your old one and reinstall the new one. So any packages that you've added, any other customizations you've done, you've got to remember what those settings are. So that can be somewhat frustrating. All right. So now I'm
Does
gonna,
R Studio keep track of all that for you?
it can, yeah, because R Studio wraps up a lot of your settings.
I think we have the package to update the R, that means install R.
I'm sorry?
I think we have the package to update the R. If you want to update it, that means install R.
Yeah.
And if you install that package and you could use that package to update your R, it is very easy.
Yeah, I think there, some people have written packages to try to do it. I've never tried to do it that way.
Yeah.
But yeah. Yeah. I literally just keep a list of all the all the packages I have installed, and I just reinstall them clean. So, does everybody have the R and R Studio downloaded? Okay, so let me just show you what R Studio kind of looks like. Just opening it up.
Where does it, where?
So, R Studio, like I said, is basically just a nice GUI wrapper. So when you do anything in R, it pops up in extra windows. What this does is it keeps it all kind of confined. So down here, you have your console like you have in the regular R. Then, and down in your bottom right quadrant, you have all the files that are in whatever folders you have, plots, packages, help, those types of things. So it just keeps a lot of the common things you do in one spot. It's just easier to use. You don't have to use it, but I do find it tends to be much easier. So one of the things I also had sent around was a Google Drive link that has a script and a data set in it.
David, can you send it again to me?
So R works, like I said, from the command console. You can do it straight from the command line, or you can use a script. And a script is really just a historical record of what you've done. It's just like your SPSS syntax file and those types of things. So this just, as I go through and I'm writing a paper, doing any kind of analysis, I always keep a record of what I've done so I can replicate it later, or someone else can replicate it later. So again, this is all exactly the same types of stuff. One of the fun things about R is that you can get started right out of the box. So R comes with a lot of built-in data sets. So that's what this first little thing here is. It says, let's look at R's built-in data. It is data with a little parentheses after it. So that just means call all the data that's built into R. So I'll highlight it, and I click this little run button up here. and it runs the code down here in the console, and then it brings up this little viewer here that says these are all the packages, these are the data sets that start in R. They're just right out of the base. You can start tinkering with stuff. And you can just, right down here in the viewer, we're going to use empty cars. So we'll start just looking at that one. You can see it shows up down here. This is what the cars data set looks like. And we'll play with that more.
Hang on.
The way you use these scripts, okay?
You're way down the road.
So the way you use the script, you can either enter anything in the command line console here, or I can highlight it in the script and click run right there.
Oh, okay.
So highlighting it and clicking run is the same as if I was down here and wrote data with the 2 parentheses in it. And you see, as soon as I type data, it has this drop down. Like, okay, these are all the internal data sets. Which one do you want? And if I just leave it blank, it selects all of them and says, okay, well, here's a list of all of them. So if I hit data, and the first one's air passengers, right? If I just select air passengers, it will bring it up over here in my values. You can see that right over there. Okay. Okay. So these are just R's built-in data. So here with the data, this is how you can look at like R's internal data that you can just play with. And you'll see a lot of people will use this data as examples. So one of the great things about the R community is that R is free and open source, and the people that work in the community tend to be free open source people. So we tend to share a lot of code, write a lot of books for free. You'll see a lot of tutorials and things like that where people just give away their code. So a lot of the time you'll see these entry-level, the internal data set used as what their example. So what we're going to do is we're going to do what you guys probably do most of the time is you get a data file from somebody. Right? And they say, we want you to do some analysis on whatever data you happen to have been given. So we're going to load in the car's data here. So remember, R is object-oriented. So everything's about creating objects. So for this one, I'm going to read the CSV file, which is called emptycars.csv, and I'm going to create an object called cars. That's how you interpret that line there. So if you highlight the whole line and hit run, it is not in the actual. Oh, that's why. I haven't changed my working directory. You're right. So one of the things that I like about that's actually a really good point we should bring up. So R lives in your program files, so it's always looking there. So one of the things I do with RStudio, which actually has made it really nice, is I go up here to File, New Project, and I don't want to save my data. So I'm going to create a new directory, this little R, the cube guy. I'm going to create a new one, a new project. I'm going to call it Workshop, and I'm going to put it just straight on my desktop, here, right on the desktop. Yep, and then create this project. So what this does, it creates a little miniaturized version of R. See, here you can see the little R inside it. It creates a little miniaturized version of R inside this folder. Now when you do that, it automatically sets your working directory. It's always looking right here. You cannot possibly pull data from the wrong spot if you've got a little project wrapper. So that's why I use these little project wrappers. Otherwise, if you say, pull it from C drive in these subfolders, if one of those subfolders changes, you could be pulling the completely wrong thing. So that's why I use these little guys. So I'm going to move the two things into this. Okay. All right. Now when I open,
it's got to be the same directory as opposed to like a subdirectory.
Yeah. So now I've got in my little project, my RStudio project, I've got a little cube called Workshop. That's what I called it, right? And I've got the script, and I get the data. Now when I open up my console, I look over here under Files. It tells me I've got my Workshop, my script, and my cars. That way I can make sure that I'm always working with the most updated data set, all the correct stuff, and I'm not pulling last year's version of something accidentally. When I run SPSS, you have to specify exactly the file path, and sometimes you'll pull last year's data. Does everyone follow what the project is?
So if you wanted to look at your script again,
Mhm.
it has now disappeared.
Yep. I just click on script,
You
and
just click on script
yep,
and it
pops
shows
right back up.
Okay.
Yep. So now that the data is actually in the right place, otherwise I would have had to specify right here, C/, desktop kind of stuff. But I'm not going to do that now. Now it's just empty cars, run the CSV. See over here, in my little data spot, it says, well, there's cars. This is what you want to call it. I can see what variables are in it. Sorry.
Oh, I got it. I got
Okay.
it. I see it now. Okay.
I can see,
It just took a second.
hit the little drop down, I can see what variables are in it and what the types of variables are. So the first one is model. It is a factor with 32 levels. A factor is any kind of nominal variable, eyes, gender, whatever you want to do that is just something descriptive. The next one is MPG. It's a number. It's just continuous variable. So you have to make sure these are set properly, because you can have a factor that is numbers. Like if you have a student ID code, that is technically a name of a student that just is in the form of numbers. So you have to be careful that you specify that as a factor, not as a number. Otherwise, we'll try to add them all up, and that doesn't make any sense whatsoever. So we're actually going to look at this cars. If you click on it, it'll pull up in the little data viewer up here. Mm-hmm.
So what you're doing there is you're basically telling R what kind of variable you've got,
Yep.
and what it can do with that thing by
Yes.
defining this is what you are, this is what
Yep.
you do.
And we're going to talk about changing that in a little bit.
Okay.
So this is where you can see your data. You can also import the data right from like a text file. So there are from Excel, from SPSS, from Stata. I don't use these often because I tend to live in the world of CSVs. Everything just comes in that way, or it's like when I use a lot of WinSteps for the psychometric, so I get a lot of just column files. So just straight flat tables rather than I don't use Stata ever, so I never have a reason to import it in Stata. But so I don't have any personal expertise with these couple of options, but I'm sure they work. I've just never tried it. So now we have cars in our data, and it's loaded as an object. So once it's an object, you're not messing with the original data ever. So this is just loaded into R's working memory. So any changes you make here are not saved until you tell it, save this file. So whatever you mess with, you can always go back and fix it.
So when I did view cars, it said error could not find function view.
R is case sensitive, so it has to be a capital V. So if it is a,
Did not realize it was
yep, R is very sensitive. So if you have two variables and one has a capital and one has a lowercase, those are two totally different things. So this is a very standard data set. The reason I picked the cars data set is because this is one that people use in tutorials all the time. So if you get into R ever and really start working with it, you will see people talking about using the MT cars a lot. So that's why I thought we might as well start with one. And each car here is a different one. It's not like we've got multiple rows for the same car or anything like that. So, and it has lots of different factors. There's lots of reasons why you would pick this one as your sample data. So,
Do I need to put the air quotes?
yeah, you need more quotes in the parentheses. It always has to be wrapped. So, but it will tell you, like, if I don't have a parentheses here, so I've got my thing right here in my script, all of a sudden everything just goes crazy. Because it's like, you've got a problem with your code somewhere, and now I need to find it. So I said before that with R, there's a base version of R, okay? And you can see it over here in the packages. This is all the stuff that just comes with it. And there's a lot of good stuff there. I mean, most of what you use can be done in base. But there's also a lot of really cool stuff that people have built packages for. And one of my favorites is the first one I'm going to show you is Ggplot. So this is a package built on the grammar of graphics. So it's a very robust graphics package. And it's one of the reasons I got into R in the first place, because I got tired of SPSS is terrible graphics rendering. So this is how you install packages. You just click install .packages ggplot2, and then you hit run. Or you can go into RStudio has these little update and install buttons. If I say install packages ggplot2, and it'll tell me where I want to install it, install dependencies. All of these programs, these packages, use pieces from other packages. So you just have to make sure you have all the pieces. So just don't unclick any of that. So I'm going to click install. And you'll see down,
The packages, okay.
you'll see down here it does that. Install .packages ggplot2. It's the exact same code I've got up here. Now it's just downloading like all these little pieces of the packages, putting them all together. It's going to check it's going to make sure they're unpacked. Now there are sometimes problems because our packages come in as zip files. So if you're behind a firewall that blocks zip files, you will have problems with some of these. RStudio's CRAN, when I talked about CRANs earlier, if you go to theirs and are always kind of pulling stuff from their server, they are, I can't remember what it's called, HTML5 firewall free or whatever it is. So they tend to be okay, but some of the other CRANs don't. So I'm just going to highlight the next two. Plier and Reshape 2. Plier is, these two are data manipulation. So obviously Reshape is you're reshaping your data. And Plier is like a pair of pliers. It was this joke. So a lot of our packages have goofy names because I guess why not? So I'm going to highlight both lines and run that. So this will install both of them. And you can see here it says everything's installed, successfully unpacked and checked. So now I'm good. I go over here to my packages list. And I can see, where is it? No, system. I can see ggplot2 right there. I don't know if you guys can see that or not, but you can see it now in your list of packages. So now it's installed, but just because it's installed doesn't mean it's active. So that's when you have to go to this packet, this library. Now what I say is, go to my library. All my packages are stored in my library. Go to my library and load ggplot2 so I can actually use it. That's what I'm going to do right here. And it doesn't actually throw me any problems. So if I...
Highlight that one.
Yep.
All right, what does this require thing do?
Require and library, I was seeing if it threw me an extra error after that. So require and library are two slightly different things. If you require a package, it will throw all kinds of errors at you if something bad happens. If you just tell it to go to the library and grab it, it might tell you it didn't load, but it won't tell you why, it won't tell you any other information. So I tend to use require more than library just because I want to know exactly why something is not loading, but it doesn't really matter. They do at the end of the day, they do exactly the same thing. And so I've loaded
And you
ggplot.
could have used require instead of the word library
Yes.
up there too? Okay.
Yep, I can use require or library. What is the... So... Can't remember if that's the code or not. Nope. So I can't remember what the... there's a... Is it with? There's a command to... I can't remember what it is offhand. There's a command you can use that will tell you all the packages that you currently have loaded. And so, because sometimes you can use a package and it can't be used with another package because they have the same thing called the same thing. Like they'll both have like a t-test function. It'll say, well, you can't use that one because we need the code from this other one. So you'll get that if you... Here, I can actually show you. So I'm going to load Plier and load Reshape. Okay. Nothing crazy. They load just fine. So now I'm going to install a package.
Liar didn't like it.
Oh. Okay. So the guy, actually the same person wrote all three of these packages. And he's actually the chief scientist now at RStudio, interestingly enough. So Plier is the first iteration of another data manipulation package called dplier. And so, yeah, I'm having some problems loading this one too. I don't know if it's the internet or what.
How do we know if it loaded?
it will, it really won't tell you.
Okay.
If it doesn't say anything,
Right.
everything's fine.
Right.
If it gives you a bunch of errors, then you should start to worry about things.
Okay.
And this little command up here is how you detach a package. You just tell it, detach the package, Ggplot 2, or whatever you want to detach. Unload equals true. And that will take it out. So this is really taking a while.
And that hashtag is how I do the commenting.
I'm sorry?
Putting the little.
Yes, oh yeah. So the little hashtag, that's how you make comments in R. I tend to make these big ones at the top for like section headings. So as I'm scrolling down very quickly, looking on my code, I can very quickly see, oh, this is the analysis section of my paper. So that's how I do it anyway. Everyone's going to have their own conventions, but yeah, the little hashtag means anything after that is anything after that on that line is commented out. But this is how you would this is what you do when you detach a package.
What does detach mean?
Detach means you have a package. Like if I have plier and I have dplier. So dplier is the second version of plier. Some of the functions interfere with each other. So you often have to detach plier in order to run the second version of dplier. So you'll have to detach it. And see, now, if I try to do something with ggplot, it would just give me an error and say that package isn't loaded.
So does detaching reverse the install or reverse the
It
library?
reverses the library.
Okay.
If you install it, it's always there.
Okay.
Yep. You attach it with the library, you detach it with the detach command. And then once you have all these packages, you can actually, one of the nice things, like I said, it's open source, so you can see inside the packages. So this is the stats package, right? And these two little dots mean say, okay, I've got the stats package, and I want to look at the function inside of it called predict. And if I run that, this is the code it runs. You can just see a bunch of if-elses, there's a for loop in there. That's how it runs the code that tells you what's inside that package. You can also do get anywhere. So if I do get anywhere on Fisher Z, no, it didn't do it. Need psych. Oh, I didn't have psych package in here. That's interesting. All right, so I'll do the predict. So predict does the same, or get anywhere does the same thing. So you can look inside the packages and actually see what's going on underneath the code. So I've had instances where I've been working on something and my computation doesn't come up the same as a different package. Or two different packages conflict and give me different numbers. So I can actually open up the packages and go, why are these different? What are these two packages doing that might be giving me the wrong or conflicting information? So you can get in there and check it under the hood, see what's going on.
So how did you make that appear?
This-
On this-
This stats is the package, and a predict linear model.
Right.
That's
And
That's-
you to see the code.
it just tells you the code of that function.
It just does.
Yep.
Okay.
And then this get anywhere also does the same thing. So those are two different ways to do kind of the same thing, to see inside these functions. Now I've just thrown, I guess I just thrown another word at you. So functions are these little bits of code that say like view, right? That's the view function. They're packages, like a stats package, that has a function of t-test, something like that, okay? So the terminology can take a little while to figure out what everyone's throwing at you. When you start reading these, like Stack Exchange and some of these other like stats heavy, big nerdery types of websites where people get going, they'll start throwing these words out. It might take you a little while to kind of get up to speed. Well, so that's kind of how you get it loaded, how you get it started, and how you look at some of the data. I think we've got our data loaded in. We're using cars. You can see it up here. You can tell what kind of variables they are over here. So like this VS, it looks like it's an integer of just ones and zeros. So that might just be a dummy variable for something else.
Okay, where did you come up with those cars up there? They didn't appear for me.
So when you click on stuff in RStudio, it's just calling the regular console-based function, just using a click function. So here's our data. All right, so let's play around a little bit with it. So we've already done the view. str. That is just tell me what my data is. What are the data are? Tell me what my data are. They are, again, this model factor. So it looks just like this up here. This little button drop down just pulls the str function. That's it. So you can see integers. There are some minor differences if you start talking about integers and numbers. And what those are, I am probably not the right person to tell you. Some really complicated under the hood coding stuff that something happens. If you hit summary of cars, I'm going to summarize my data. It will give you just kind of a quick hitter. Okay, so based on my model, everyone's just a 1. Mile per gallon, here's the min, mean, max. But those are because there's numbers. So later on you'll see, well, I guess they're all min, mean, max except for the cars. So that just tells you what your factors are. So if you had, if I have a factor like gender, it would tell you probably just male, female, or anything else you have listed on the list. Male, female, and it'd be a count. So that's just how it summarizes like factor data. So, but these all happen to be numbers, integers or numbers, except for the actual model of the car. So, like I said, I've got a little note here to talk about different types of factors, numbers, characters, integers. You can have a character be 1, you can have a character be 77, or you can have a number be 77. So you've got to make sure when you look over at your data that it brought it in as the right kind of thing. And down here, I'm going to use this little t function. T in cars. I'm just playing around. I'm going to make this other little object called t cars. So when I do that, see it pops up this other little guy here, t cars. It's a second object. I haven't altered my first object in any way. I've just created a second one. And that T just means transpose. It just totally flips the matrix on its head. So it doesn't make any sense because it's just looking at it a different way. So if you're using matrices or anything like that, you can try to flip them back and forth. And R is great for different types of data manipulation. That's just one. That's just kind of fun, just as a goof. But that's how you make a separate object. Now this object has not at all changed the way cars looks. They're two totally separate things. I haven't edited anything. So this is how I make a matrix. Remember, I've got my matrix. When you want to combine things, R uses this little C function. It's a C in the parentheses. It means concatenate. So we're joining together matrix of 2, 4, 3, 1, 5, and 7. I want the number of rows to be 3 and the number of columns to be 2. So I've just.
What are these 2, 4, 3s?
They're just random numbers I made up, pulled out of thin air.
Okay.
So I'm going to make a matrix of this. I want 3 rows and 2 columns. I'm going to call it Matt. And here's what Matt looks like.
Oh. Okay.
So I've got 2 columns, 3 rows. The guy on the left here, this is my row numbers. All your rows get numbered in R. And so that's how it keeps track of a lot of things. So when you save things, you often have to tell it, don't include the row numbers, otherwise there'll be a column of just numbers next to it. Yep, and then if I do use my little tmat, so now I've got Matt and I've got tmat, and it just flips them. Again, that's just how you transpose matrices. So you probably won't use this a lot, but there might be instances where you'll be like, oh, I know, there's a very simple code to totally flip my data around, because I do this more, I do it in Excel where I'll have to highlight the whole bunch, have to copy it and paste as a special, and there's a whole transpose thing there. So I do that more often than I care to admit. But that's just like something about the matrices. You probably won't use matrices a lot, but that's how you concatenate things, that little C function, and we'll play with that in a few more minutes too. So we have this function, or this variable called cylinder, CYL. Right? It's this guy right here. It's an integer, 4, 6, 8. Well, as far as I'm concerned, that's not really an integer so much as it is a description of the type of engine it has. And I'm not really a car guy, so don't hold me to that. But so what I'm going to do is, because it's only 4s, 6s, and 8s, I'm going to convert it to a factor. So I have this as factor, cars, and that $sign is the separator between, tells me what data set in which variable. So you do that, you will wear out the $sign keyboard or button on your keyboard. So I want to take the cars data set, the variable CYL, and I want to make it a factor, and I want to call it the same thing. Okay. I could call it something totally different, and it would just give me another column in that same data set. So actually, let me just do that. Let me call it CYL2. So now when I look at cars, at the very end, I have this other thing called CYL2. It's the same thing. I mean, the data is the same. But you can see at the bottom, it's a factor with 3 levels. So now when I do my summary of cars, and click on my little summary guy here again, you see the CYL2 at the very bottom here is just a count of 4s, 6s, and 8s. So that's how you transform like a number into a factor, and you can go backwards and forwards. You can say, you know, this is all these numbers, but I actually want them to be not IDs. I want them to be actual numbers, and you can do it backwards and forwards like that. Although taking a name and making it a number is somewhat more complicated because you might not do it right. But so that's how you just kind of make different things into factors. Most of the time when I'm doing this, it's because I got a list of students and I have all their ID codes, and it's not really a number. The ID code is a name. I just want to make it a name so I can count them later. So I convert the ID code into a factor, and I can just use it to calculate other data. Okay. So everyone kind of follow just the basics of that. All right. So now I've got a number of other little data sets up here, or little objects up here. But we're going to work on subsetting, because here I've got a big data set. And what I want really is just the 4-cylinder cars, just the little guys. So what I'm going to do is I'm going to subset my data that's cars, and I want only ones where the CYL is exactly equal to 4. That's what the double equals means. Equals means is equal to. The double equal means is exactly equal to, no exceptions. It's much more forceful. I don't know why they felt the need. I think equals means equals, but I didn't make the program. So when we do that, I'm going to make this other object called CYL4. And now I've got my little CYL4. Now it's only 11 observations of 13 variables. So it's gotten rid of all the 6s and the 8s. So you can actually look at it here, and you can see CYL4 for all 11. But it keeps the row number, see? That's how you can kind of link it back all the time. It always keeps that original row number. So later on you can go, hey, remember row number 8? Yeah, I want that one, and I want to slide them back into the original data. Probably not a lot of applications for that, but it is kind of a neat thing just to have.
So this command is similar to a select command, or
yeah.
I want to condition my data only on this group. Or
Yeah.
I want a subset.
Yep.
Now, when you did this with the cylinder, you used the original cylinder, which meant you used the numbers. It didn't matter whether you were going to use the numbers or the factor, right? It was going to work.
I was just selecting 4, right? Because if I used, where's my cars? Right there. Or I want the I want the CYL4. So now what I did is I just selected those. It's just a subset of that data again.
Right.
Yep.
Yeah, but it doesn't matter what kind of variable the
Nope.
CYL is at that point. It just
Right.
you tell it, I want that done.
Let's try this. CYL2. Now this is going to yell at me. Well, it should. It didn't. Let's actually call it 4.2, just to make sure we've got something different. So it actually didn't, because it is the same thing. Often what it will want there is it will want quotes around that, because 4 in that case is a factor.
Now, would you not have to put the CYL2 in the front?
No.
Oh,
Okay, so we want a subset.
what does the CYL? What does
Yep.
the CYL say in the beginning? doesn't that tell you the variable that you're gonna use?
Yes. So CYL4 is the new one we're making. We're going to make a new object.
Oh, okay.
And this little arrow.
Okay.
Oh, it's not giving me my controls. Okay, so this little arrow says push the subset of cars into this other object. So you also use that little arrow sign a lot. Okay, so that's how you make a subset. The next one is I want to make a subset, the CYL4 MPG. Again, I'm making a subset of CYL4s, so I'm going to this other object.
Right.
And I want to select only these two columns, model and miles per gallon. So now let's look at CYL4 MPG. So it just has model and miles per gallon. That's it. So I've taken, so if I will have data which has like 300 columns, which is really awkward. If I know I only need like 5 of those columns, I'll just yank those 5 out and put it in a totally new data frame. Data frame. When you start talking about different types of data, talk about matrices are just boxes, but they all have to be the same thing, all have to be numbers. A data frame is just like your normal average kind of flat file, which is what most people think of when they think of like an SPSS or Excel file. So there is a difference when you start talking about lists and arrays and data frames and matrices. It gets complicated. So 90% of the time it's going to be a data frame. So that's what we're dealing with. But there is more complicated stuff later. So now I can do one. Let's do this other one. Cylinder 4 and 6. So I want a subset by cars. So pulling from the original data. If the cylinder is 4 or the cylinder is 6. Okay?
So that's the straight bar, right?
It's a straight bar, yep.
Okay.
The ampersand means and. So if I want, the cylinder would be 4 and 6. We can't have 2. Not in this data set, so it wouldn't make any sense. But if we just do this one, it's going to pull 18 observations where all the cylinders are 4s and 6s. So that's how you can do, if I wanted to just kind of keep shrinking my data, I want to pull this one. Well, what about these variables? What about these variables? You can cut it up this way so it's easier to use. And this last one is, I just call it CYL 6 and 4 just to have something different. It's the exact same thing as 4 and 6 because what I called was exclamation point before the equals. That means is not equal to. So what I wanted here was I said, give me a subset of cars where the cylinder is not equal to 8, which by definition means it has to be a 4 or a 6. So it gave me exactly the same data.
Mike, I like that feature about how, like, my guess is if you had actually just put your cursor on that line, and just leave the ampersand, that it actually would have came back maybe with an error message that and was at the end.
Yeah.
Versus you had highlighted it, and so
Oh, yeah.
is smart enough to know that, oh, that's all you want me to do.
Yep.
And so I will ignore anything else. Go
Yeah,
on.
like I was showing him earlier, if I had this, all of a sudden it says, whoa, that's crazy. You need something else here. So now I go back up, put my parentheses back. Now all my errors are gone. Like it does, RStudio does kind of figure out, and this is an RStudio feature that figures out that you need to do some work to your code, something's going to break.
Are there any limitations to RStudio when interfaces with R in terms of like there are things that you can do in like the full R that RStudio will not interact with?
I haven't found one yet.
Okay.
Because mostly all RStudios is just a wrapper.
Okay.
It calls R in the background and just puts this nice little face on top of it. That's most of all it's doing. So
really, it sounds like there's really probably no reason to just do R. Just do R with the R Studio, and you're good to go.
I almost never open it. My original R, the regular command console. I almost never open it. There's never a reason for me to. I just open it. Whenever I have a new thing to do, I start by making a new project, putting whatever files I need in that new project, empty project, and then I just work from there. I open a script and I start typing, load that data in, and I go from there. So that's how I do everything. So that's how you subset different data. Did anybody have any questions about the subsetting? The ands and the ors are relatively straightforward once you get the hang of it. But the next thing is renaming variables. So obviously you have variables that come in that have goofy names and you want to change it. R doesn't like spaces, like a blank space in a variable name. It does not like it. It will insert a period between blank spaces. Not an underscore, a period. So you'll see that a lot. If you bring data in that has, like, if student names is the variable and there's a space between student and names, it will bring it in and put a dot between them, just because it doesn't want there to be any confusion about what the name actually is or which name you're calling. So here, what I'm going to do is using base R. If I can, this is really thrown at me. Using base R, I'm going to show you how to rename a variable two different ways. If I call names, so now I'm talking about all the names of all my variables. The CYL4 MPG, and I just want to call it MPG, or I want to take my MPG and call it miles per gallon. See over here, I've got miles per gallon is what I want. I go over here, and now you see the name has been changed here at the top. But I've never found that to be the best way to do it. So there's a function in plier just called rename. So if I have plier loaded, I say, okay, in my CYL4 MPG object, I want to rename from the same thing. You could call it something totally different if you felt like it. Again, all different objects. I want to make miles per gallon equal MPG. And here what I'm doing is I'm turning it back. So the first time I took the cylinder 4 and I had it say miles per gallon, and then I flipped it back. I find the rename function to be much easier because you can just sit there and say, I want to rename that, comma, disp equals whatever else. You can just hit comma, and just keep doing different variables throughout the whole thing. So I find the rename to be good, especially if I'm renaming a number of different variables in the data. Because there's some data I've gotten before where the variables are all numbers. And then you've got to go to the code book and see, what does this number mean? And then I have to actually manually type out all the names, and that gets pretty tiresome.
On line 77, the line you're in, what does the C stand for? The C in front of the parentheses?
The C in the parentheses, it means concatenate. It means
Okay.
join together. So whenever you have more than one thing, you use a little C parentheses, put it in there, and then there's a comma. Excuse me, a comma. So for this, it would be miles per gallon equals MPG, comma, model equals car name, comma, whatever else you want to do.
But if you're not doing more than one, you didn't really need the C to start with.
For this, you do, because it's programmed that way. The plier package has said, look for anything inside the C.
Oh, okay.
But yeah,
Okay.
but it makes sense that if you didn't have more than one, it wouldn't make a lot of sense. But yeah, I know what you mean. So that's how you rename a variable. Recoding data, and again, you can do it in a couple of different ways. So this is looking at cars. I want a variable called new model in my cars data set. So I'm going to make this, I'm going to paste. So paste is the command we use when we're talking about names of things. I want the car model and the cylinder. And I want it to be separated by an underscore. That's what that means. So when I do this, when I run this little line of code here, I'm going to go back and view my cars data now. All the way at the end, I've got this variable called new.model. It's a Mazda RX-4 and it's a 6-cylinder. So I've just made up a new thing. So that's how you combine two names of things. So you can make, if you want to have a variable where it's the student's name, like the student's number, their homeroom teacher, their grade, all in one field, you could do that with the paste function. Just paste them all together. With whatever separation you want, a comma or a space or anything. So get rid of some of these other, X out of some of these data up here. Okay. So also R is basically at heart just an enormous calculator. So if I say I want cars, this a new variable called miles per gallon dot disp, and I think there's some relationship between the miles per gallon and whatever this disp variable is, I think engine displacement. So what I'm going to do is I'm just going to divide those two by themselves. So, oh, come on. So I go back up to cars, and now I have this other variable way here at the end, which is just the calculation of miles per gallon over disp. So you can calculate things. You can just do whatever you need to do to and create it and store it in a new variable.
So on that one,
Mm-hmm.
you could theoretically calculate the miles per gallon divided by the cylinders, right?
Sure.
As long as that's a number.
As long as it's a number, yep.
Will it give you an error if you've turned your cylinders into a
Mhm.
factor?
Yeah.
Okay.
I'm not sure. I can't remember what the error is. Not meaningful factors.
Makes sense.
Yep. All right. So the next one is, all right, so I've got this other thing. I want to call it, I don't really even know what this means. I just completely made this up. So I've got cars, and I want a new variable called cat, just category. That means I want the cars, it wants to select anything with the HP is greater than 50 and the DRAT is less than 0.3. I just completely made that up because I had no idea what I'm talking about. So, and I want to call that fast. Like somehow I think that means the car should be really fast, right? I don't really have any idea whatsoever, so, but I'm going to make the variable anyway. I'm going to look at my car's data and slide all the way back, and it's going to be fast. That one's fast. That one's fast. That one's fast. Okay, the rest of them are just NAs. I didn't tell it to do anything else.
Is there an easy way to say else slow?
Yes, you could just run an if-else statement, which I think might be. It's later on, but yeah, you could say you could run multiple versions of that if you knew exactly that everyone was
So you're doing another
independent.
line, not this logical statement.
The next logical statement, and it would write over the NAs with the other thing. Or you could do you can do a lot of if-else statements, like if it's that, then fast, comma, slow. And then it would be, everything would be populated with one or the other. And you can nest those if-elses. Those get pretty complicated pretty fast, though. Unfortunately, I hate to admit that I use that a lot, the nested if-else statements. So that's just how you kind of calculate new variables, add new columns, change stuff around. You're kind of your bread and butter of your data manipulation. One thing you can also do is combine rows and combine columns. So if you have a data, I actually had this just the other day. I have one data set has all the scores for people, but we don't keep that with all of their demographic data. Those are two different databases. So the database shoots out the scores, and then this other one shoots out demographic information. So I have to combine them. So there are a couple different ways you can combine them. And one of them is to use the cbind, which means column bind. And there's rbind, which means row bind. And this is just taking two columns and literally smacking them together, or two rows and just smacking them together. So for this one, I'm going to set the seed at 1, 2, 3. That's just R babel for make this replicable. So now I want a normal distribution, 32 observations with a mean of 0 and a standard deviation of 1. So I'm going to call this normal. So here's my normal value. So you see it down there in values, it is not a data frame. It is a list currently. I think it's a list. So, but now I'm going to make it a data frame. I see normal as.data.frame. And that pulls it from being the values at the bottom to being a regular 32 observations of one variable. Right. So that's part of how you have to know what type of variable you have. In the first instance, I had something that was just a list. And I said, no, don't make it just a list. Make it actually a column with different cells. Otherwise, what you'll get is literally one cell that has every number in it separated by commas. And just this one big cell like this. It just looks goofy. So,
if you ran that again, would it generate a different subset of 32 cases?
and so let's do this. So normal 2 is that. Yeah. So that's the second seed. So, but the first time I do it, if I go back, let me do a 3 now. Only so we can keep our numbers straight. Okay. So if I reset my seed at 1, 2, 3 and redo the norm, and I'll do normal 3 and normal 1 are exactly the same.
Because you gave it the same.
I told it to set the seed at this. Now the first time you replicate it becomes this. The second time, but if I did it again, it would be the number 2 again. So that's how you make your simulations or things like that replicable. So that's why I set the seed and thought we'd just do it once. That way everyone would get the same thing. So now what I'm going to do is I'm going to take my cars data and I'm going to C-bind. Again, I'm binding the columns of cars to normal, that normal distribution. I'm going to run that and look at my data, and it just literally just slapped them on there. And now that presumes that I've got them all in the proper order, which can be somewhat dangerous assumption to be making. I don't use C-bind nearly as often as I use row bind. With row bind, it's just appending data onto itself. So if you're stacking data on top of itself, I use that a lot. It is again, it assumes the columns are the same, and if your column names are not right, it'll blow up on you. It'll say, "Yeah, you can't do that."
Just back to these columns one more
Uh-huh.
time. So you're just mushing them together no matter what. You're not looking at, do I have
Nope.
that's in common in both of them?
I am making that assumption, which is a
good.
bold assumption.
Oh, okay.
So in a
It's a disaster.
yeah, yep, you should. You should see that exactly. And so this is what we're going to do, is we're actually going to do it a little more scientifically and merge the two data together. So here I'm going to create something called models. It's a subset of cars. I just want the model. And then I want to C-bind the model with the normal data, okay? So now I get this other file object here called models. Now it is a model with the normal distribution that we created, okay? Now we have a unique identifier between the two data sets. The name of the car. So there's two ways to do joins and merges. There's actual merge, which is a base R function, and join, which is a plier function. The nice thing about R is it does any kind of join you want, inner join, outer join. Do you get anybody here know like SQL type of talk as far as joins? Inner join is data that's only in common between the two data sets, so it has to be overlapping. Outer join is everything in each of the data sets. A left join would be just the stuff this way, and a right join is just the stuff this way. So it depends on which way you're looking at it. So that's why I'm going to merge cars and models by equals the model variable, because that's our variable that's in common between the two, and all equals true. That means I want everybody. Now in this case, I don't have to specify that because it's exactly the same 32. But if it were not, if I had one group, if I were trying to merge the data from the freshman class with just the people in like one specific biology class, I would want just to pull out 30 students. I wouldn't want 3,000. So that's when you would use just a left join or a right join, or an inner join. So we're going to call this cars 2. We're going to run that. And now you see that I've got, again, the model, but all the way at the back here, I've got this other thing called normal y. And the reason it says .y is because there were two variables called normal on the join. And so it said, okay, well, one's from the x join, one's from the y. But we got to make these different somehow. But you can see they're exactly the same thing. So that's just a function of having already had a column in that data called normal, since we already did it. Join works the same way. You just have to load plier first. So you load plier package, join cars by model, type equals full. That's where you start talking more about like full outer joins or inner joins, get more into like SQL-y type of stuff. And if I do that, cars 3, merge cars with models. Yeah, so it actually didn't give me the X and Y on this one. It just gave me whatever the second one was. I'm not sure why. But so there's 2 different ways you can do data merges. It depends if you want to just do it in base R or if you want to use plier. It's really more of a personal preference. I haven't really found a benefit to using one or the other. So that's just kind of some data manipulation stuff. And there's lots of books on data manipulation in R. Like I said, the guys that wrote, Hadley Wickham's the guy at R Studio that wrote Ggplot and plier. He's written a bunch of other packages. He calls it the tidyverse, trying to make your data neat. And so he's got like this suite of tidyverse packages that help data manipulation. So they're really big into it, and R Studio has a lot of cheat sheets and stuff like that. So just now that we've done some basic data manipulation, we're going to talk about actually how you calculate some of these things. So it's actually relatively simple. Here I want the mean of the car's DISP, and it tells me down here the mean is 230.7. SD, clear standard deviation, 123. You can also push these into objects if you like. So I'm going to push it into an object, and it is literally just going to be the value stored down here in a single, essentially it's a single cell, but it doesn't have a title, column, or row name. So it just stores it as one thing. So then I just call x.cars, and it's right there again. So you can make just a quick table of the cylinders. Again, this is just what the summary looks like. Remember that? So 4, 6, and 8, that's just a count. Nothing super exciting. Now if I want a table, like a cross tabulation, the car's cylinder by the whatever VS means, I have no idea what that is. There's CYL 4, 6, and 8 by 0 and 1. Problem is it doesn't give you any labels. So if you have things that are just yes, no's versus yes, no's, or 0, 1 versus 0, 1, it's hard to figure out which one's which sometimes. But that's just how you do just kind of a very basic table. So, but in this here, one of the problems is when you calculate a mean of something, if there's an NA anywhere, it will not just skip over it, it will break. So you have to specify NA remove. So if we do, here's an if-else statement. If else, if the car's QSEC is greater than 20, give me the car's QSEC. So if it's greater than 20, just leave it. If it's less than 20, throw me an NA. So let's look at this car's NA field here. So here's the NA. Here's the QSEC, and you see it's got a bunch of NAs, and then if it's over 20, it left it over 20. I need to start deleting some of this, get back to my script. So now if I want to calculate the mean of the cars, it just gives me an NA. It says I can't possibly calculate a mean when I have all this missing data. That's why you need this little NARM, that NA remove. So what that means is it will remove every instance of an NA, and it will actually give you the mean of what's left, 21 point something. So you've got to remember sometimes certain things need certain quick little snippets at the end to make sure that they calculate things properly. But in this case, it's easy to tell. I mean, if you ask for a mean, it gives you an A, you know you've done something wrong. Okay, so this is where I'm going to get into some more of the little bit of fun stuff. I guess we're running out of time too. So just to show you some of the plotting functions. So this is what base plots look like. And you see it down here in the bottom right-hand corner. When you do a plot in R, it shows up over there. And it keeps track. These little arrows up here will move back and forth. So that's the base plot of that. That's another base plot. Okay, so this is just what base R looks like. You can see down here it's just the cars, disp. It's just a variable, as you'd call it, by that. It's not super exciting. You can do different stuff in base, but this is what just the base package will look like. And I can go back, and now that I've loaded them in, I can go backwards and look at all of them again. So you can see how they change if you make a change to the axes or whatever. So I've also included a link in here to the RStudio Ggplot cheat sheet right there. So that might be helpful for some people if they want to go back and learn about the Ggplots. So like I said, this is based on a book called The Grammar of Graphics. So there are some very specific rules with Ggplot, like you can't have two y-axes, because having two y-axes is often cheating. You're basically trying to trick people. So he made it explicitly where you can't have two y-axes.
What if you want to graph two different things that live on different networks?
Then you should have two different graphs. That would be his proposition, that you should have two different graphs. So, yeah, you can do that in base, but you can't do that in Ggplot. So you take the Ggplot call, and you say, I want to plot something from cars. AES is the aesthetic. These are basically your x and your y variables. So my x-axis is disp, my y is NPG, and then I'm going to add this thing down here called a geom. It's whatever you want your geometric representation of that plot or point to be. It can be a geom point, it can be a line, it can be all kinds of stuff. So we're just going to do the very basic Ggplot. So that's what it looks like down there. But you have a lot more control over Ggplot than you have over base. So I'm going to do let's see. All right, let's just do the whole thing here. You see, I've got some stuff commented out. So now what I've got is I have a geom point. I want a scatter plot, and a smooth linear model equals linear model. So give me a low S smooth line through the dots, and it automatically comes with confidence intervals. My theme is classic. That's when I took the gray away. You can see right here, it's the gray background with the little white hashes, and that's kind of the default. I happen to like the classic look, which is a much more scaled down white background, but that's under your theme. There's different types of themes. It just makes it a lot faster to do some of these things. Different journals require different types of graphics, so this is how you can kind of control some of that. And then I wanted my GG title to be my plot, which is what it's got up there. Now when I save this, here, let me do this quick. I'm going to make it into something called my plot. So now I've saved this. Now I've saved this as an object. It should be down here. Is it not going to work? Yeah. So let me open up my. So I have this in here. I've got a JPEG from my plot. This is a picture. Just a regular old JPEG image of what my plot is. So that's how you get them out of R. But one of the things I did here, you can see GG save my plot as a JPEG, and I tell it what my object is. You can specify your height and width, so you can make sure that it fits what you want it to fit. Otherwise, it will just come out as whatever default is, and it could be enormous. Might not always look like it looks like in that viewer. You can also specify your DPI, which is dots per inches, which has to be more than 300 for almost every publication quality journal. So Excel comes in at 150, I think. So most places don't like Excel files for that. So that's why specifying your DPI is important. That's the basic of plots. You can also do these types of things here. So this is a facet plot. All right, so I've just separated them out by 4, 6, and 8. Now you cycle was the heat. Let me use Sil 2. It should make. No, they're just colors of different. I've specified that I want this. Well, let's put it on. I want the color to be whatever was in that variable cycle 2 or cylinder 2. And I want this thing called a facet wrap by the CYL. So it's 4, 6, and 8. And then it colors them by that. So you can just make all kinds of crazy charts. And this has been really helpful if you have a lot of different conditions for applications or things like that. You can put them all in one JPEG. So it's just one big, instead of having like 1,000 little tiny ones, you just get one big one. So I found that actually to be really handy. Just some basic stats. This is correlation. Those two things. It tells you the T statistic, degrees of freedom. You can push this all out of objects into it. T-test is the same type of thing. Although it doesn't mean a whole lot here. It's just as an example to show you that this is what the output from statistics look like. And you can push them all. If you push them into an object, you can pull out the coefficients, you can pull out the confidence intervals and those types of things. So we won't get into writing functions. This is where you can write your own functions and using loops and things like that. But that is stuff that you guys can play with on your own if you want to. That's why I've just thrown the code in there just so you have something to tinker with. And I guess that's probably about time. I'm happy to stick around and hang out and talk about this for a while if anybody else wants to. So.
Thank you.
Thank you.
Yeah. Thank you.